function. So sketch the graph and show all the work. Vertical asymptote, horizontal asymptote, X-intercept, Y-intercept, and the hole in the graph. So first of all, let factor this graph. Okay, let me take a white color here. So now let the factor this function here. So this here is just let me erase everything. So this is x cubic minus x divided by x cubic plus 2x squared minus 3x. So first of all, let's take a numerator x cubic minus x and let factor. So this is the factors is x times x squared minus 1. And this is the difference of the squares, so we can factor, and is x minus 1 times x plus 1. So we factor the numerator, and same thing we are going to do with the denominator. We are going to factor the denominator, which is x cubic. Okay, is x cubic plus 2x squared minus 3x. So x is the factor, and here is x squared plus 2x minus 3. But again, this we can factor a little bit further, this quadratic polynomial. The factors of 3 are 3 and 1, and to reach this 2 is a plus 3 minus 1. So now we can factor x is equal x times x plus 3 times x minus 1. So we found factor. And now instead of this function here, f of x, we are graphing this function. Instead of this function here, we are writing the same function, but in terms of the factors. And this can be x times x minus 1, so these factors here, for the numerator, x plus 1. And down we can write these factors here. So it's x plus 3 times x minus 1. And what we can simplify here. So here we can simplify x minus 1 with x minus 1 and x with the x. And what remains? Now remains the f of x is going to be equal with the x plus 1 divided by x plus 3. So this is a 3 here. X plus 3. And now we are working with this new function, and we are going to graph here. But before I do, I am going to work with this function. I am going to erase everything to make some space here. So we need some space. And first, let me know here, what did we simplify? We simplified the x. Because we simplified x, so x we equate with 0, and x is equal to 0. Here is a hole in the graph. And the other one, we did the x minus 1 equal with 0. Because x minus 1 we simplified, so x is equal with 1. So those two are the holes in the graph. X is equal with 1 and x is equal with 0. So those are the holes in the graph. But for the rest of the elements that we have to find here in the graph, the other points, so let me make first of all this one with a white color. Let me go. And now I'm going here with the white color. So first second, in fact, because the first one we already got here the whole of the graphs. So second point, let's find the vertical asymptote. To find the vertical asymptote, we take a denominator here, x plus 3, and we equate with 0. And we solve for x, so x is equal with a minus 3. So this is a vertical asymptote. 3. Let's find the horizontal asymptote. So horizontal asymptote, we take a numerator and denominator, and we look for degree. Degree here is 1 in numerator, and in denominator the degree of the variable here is 1. And now to find the horizontal asymptote, we take the leading coefficient in this polynomial and leading coefficient in the polynomial denominator, which happen to be 1 divided by 1. This is 1. So the horizontal asymptote y is equal with 1. And let's find the x-intercept. To find the x-intercept, we set a y is equal with 0. When we set a y is equal with 0, or f of x is equal with 0, and we take a numerator here, so we take in a shortcut. So f of x is equal with 0, and we take the numerator, which is x plus 1. And we solve for x, so x is going to be equal with a minus 1. Minus 1, so let me write a little bit better, this one here. Okay, so x is equal with a minus 1. So this is the x-intercept. And the 5, we are going to find the y-intercept. When we find y-intercept, we set x is equal with 0. So x is a 0, here is 0, 0. So, and we can find the y-intercept. F of 0 is going to be equal with a 0 plus 1 divided by 0 plus 3. So, and this is 1 over 3. So, y-intercept is 1 over 3. So, those are the points. Now, let's take all these points here and let's plug in in the graph. So, first of all, we take this x, the vertical asymptote. Vertical asymptote here is x minus 3. So we go into minus 3 and we are drawing the vertical asymptote. So the vertical asymptote is here. So vertical asymptote x is equal with the minus 3. Now we are going with the horizontal asymptote. Y is equal with 1. So 1 is here. And horizontal asymptote is going to intersect the y when is equal with 1. So now this is a horizontal asymptote is 1, so this is a horizontal asymptote. Now we are going to plug in the x-intercept. So the x-intercept is minus 1. So minus 1 is here. And y-intercept 1/3. 1/3, let's say, is here somewhere. And now we are going to write here down to connect those points with the graph. So here the end behavior of the graph is going near the vertical asymptote, and now we are going to connect those 2 points. And again, and here the end behavior of this function going near, closer and closer to the horizontal asymptote. In this side, from minus infinity to minus 3, we have to choose any number you can choose here. Let's say I'm taking here minus 4. And minus 4 I'm plugging here in this function is going 4. Negative 4 plus 1 is negative 3. And negative 4 plus 3 is negative 1. And negative 3 divided by negative 1 is a positive 3. So if we are plugging minus 4 here, evaluating this the function what we have, the y is going to be equal to 3. So here somewhere. So we already know the graph of the function now is going to go through this point and is in a positive side. So, and here is going closer to the asymptote, and same thing to the horizontal asymptote. So this is the graph of this function here. But now we have something to plug in, the holes of the graph. The hole of the graph is where x is equal with 0. Where x is equal with 0 is right here. So here is an undefined hole of the graph. And the other hole in the graph is going to be where x is 1. So x is 1, I'm going here perpendicularly up, and whenever I find here is the hole in the graph. So those 2 points. And if you want, for example, for this function to know the domain, so just let me go a little bit quickly. So the domain of this graph of the function is going from minus infinity to minus 3. Where is the asymptote here? Vertical asymptote. Union is from minus 3 to the hole in the graph. Here is undefined to 0. Union from 0 to 1, because 1 is undefined, and union from 1 to infinity. So this is a domain. If we are looking for the range of the function, so the range of the function is going to be here from minus infinity. From minus infinity is going to be, but here we have some 0. And we have to find out what is in 0 if I plug in here. So if we are plugging here 0, 0, so here is going to be 1/3. from minus infinity to 1/3. And here when we are plugging, for example, to 1 here, if we are plugging 1 here, is 1 plus 1 is a 2, and 1 plus 2, 1.5, union from 1/3 to 1.5, and is from 1.5 here, from 1.5 to 1, union from 1.5 to 1, and is union from 1 to infinity. So this is the range of the function.